Welcome to Yantra Technologies. In this present video, we are going to learn the timer 0 interrupts on this Arduino 𝒂𝒂𝒏 328P processor. For that, we have provided you a sketch where the program number 4 timer 0 interrupt is written over there. So program number 4, you please open it. It will show you the timer 0 interrupt on Arduino 𝒂𝒂𝒏 328P. So what it does is, using timer, we are going to toggle this particular LED for every 1 second. Well, one may ask, what is the fun in doing this? You may use a delay function also, but the problem with the delay function is, if you use delay, you cannot do anything else during the delay time. I mean, the processor gets stuck during that time. So interrupts are really useful to save the processor's power. So in this sketch, we are once again using the LED pin 5 as the onboard LED on this kit, and here the program shows with the pin being declared as output. So on the pin 5, I am going to toggle it, and here first of all CLI, this is making the clear interrupts. CLI and SEI, these are the two functions which will either enable or clear the interrupts. So CLI disables the interrupts. First of all, you should make sure that the interrupts are disabled, and you need to set some values in the registers. These are the timer registers for 𝒂𝒂𝒏 328P processor. So TCCR1A, you should keep it 0, and similarly TCCR1B, it is also timer register, you should keep it 0, and timer counter 1, you should make it 0, and output compare register OCR1A, you should keep for 15,624. Please remember, as we are using 16 MHz clock on this particular processor, when we set the value of OCR output compare register 1A as 15,624, it is going to give us an approximate delay of 1 second. So only for that reason we are using this particular number, and we are setting the register bits TCCR1B, the WGM 12 bit to 1. So we are setting the CTC mode. Actually this is available in the 𝒂𝒂𝒏 328P datasheet. So these are the basic registers. We are writing the code in terms of the registers to demonstrate interrupts. We are not using any C functions. And similarly TCCR1B, same one, the bit CS12 also to 1, and timer SK1, this bit output compare interrupt enable 1A. So this bit also we are setting. So this enables the timer compare interrupt. And now after setting the registers, we are enabling the interrupts. So first of all, we are making sure that we are doing the register loading, and during that time we are not enabling any interrupts, and later we are enabling the interrupts. And remember, there is nothing here in the loop. So basically loop is not doing anything. You can do whatever you wish. You can print it, you can measure the sensor data, or whatever you want you do. Basically here ISR, the interrupt service routine, that to timer 1 compare vector. So only this one is going to toggle the LED. You can see whenever the timer interrupt comes, that is whenever the timer overflows, that is approximately after 1 second, this function will be called, and only it is going to do one simple task. The LED pin's digital output, it is going to write as negation. You can see this digital read of LED pin. So whatever the pin has already, it will complement it, and once again it will rewrite it. So if at all the pin is at high, it will say low. If the pin is at low, it will say high. Only one simple line. And whatever you want, you can do in the loop. So you are basically saving the power of the processor. Generally processor gets wasted. The power of the processor gets wasted during the functions what we call as delays. That is basic level of writing the code. But if you want to save the processor's valuable power, you can use interrupts rather than using delay functions. Now upload this code. Once again, make sure that you have selected the correct board, processor, and then COM port. And after successful upload, you are going to see the LED on this pin 5 getting on and off for every 1 second without using the delay function. You can clearly see that in our loop there is nothing written over there. So this happens basically with the help of interrupts and not because of the register delay. Now the code is getting uploaded here, and it's done uploading, and please see that this green LED is blinking for every 1 second. So without using any delay function, we are able to toggle this LED, or we are able to execute a task on this processor using the timer interrupts. Thank you.